All right, so section 6.5, we're nearing the end of the chapter now. We're still talking about systems of linear equations. By the end of this video, you should be able to determine the best method for solving systems of equations. We've talked about graphing, we've talked about substitution, and we talked about elimination. You haven't done a lot of picking which one is the best of those, so that's what we're going to do, as well as applying systems of equations to word problems. So example 1, we're going to choose the best method, determine the best method to solve the system of equations, then solve the system. So we really got to think about what's the best situation here. Here's a hint for you, graphing is probably not the best solution, just because it's a little bit more difficult to pinpoint the accuracy of that. So we're really asking ourselves here, should I use substitution or elimination? Substitution is best if you have a variable that does not have a coefficient on it. So remember, a coefficient is a number that's attached to the variable. In this case, all of these have a coefficient on them. So now I move to elimination. The 5x and the negative 2x can't really do a lot with that, but I do have a 7y and a 7y. If I subtracted those, they would cancel out and I would eliminate that variable. So my best method in this case would probably be elimination using subtraction. So instead of adding these two equations together, I'm actually going to subtract them. So I'll subtract 5x minus negative 2x. Remember, that's like I'm adding. So I have 7x, 7y minus 7y cancels. And then that equals 2 minus 9 gives me negative 7. Divide both sides by 7 to solve for x. And I get x equals negative 1. Now I plug that back in to solve for y. I'm going to plug it back into this first equation. So I have 5 times negative 1 plus 7y equals 2. 5 times negative 1 gives me negative 5 plus 7y equals 2. Add 5 to both sides to get y by itself. I have 7y equals 7. Divide both sides by 7, and I have y equals 1. So now my answer is negative 1, comma 1. Solved for both x and y. We're good to go there. So the next one, again, we're going to choose the best method. None of the variables are by themselves. Substitution is probably not going to be the way to go. Elimination, none of those variables, or not, excuse me, not the variables, none of the coefficients in front of the variables are the same number, so it's a little bit difficult. So that probably means I got to move into elimination using multiplication. That's what I'm going to use here. So I'm going to use that, but I got to figure out if x or y is the smartest thing to eliminate. My x's, I have 3x and 5x. I can't really multiply 3x to get 5x or anything. However, my negative 4y and positive 8y, I can multiply that negative 4 by 2 to get negative 8. That way those 8's would cancel. So I'm going to multiply that first equation times 2. 2 times 3x gives me 6x. 2 times negative 4y gives me negative 8y. And negative 10 times 2 gives me negative 20. Then I'm going to write that second equation again. I'm not doing anything to that one. So now I've multiplied. Now I just eliminate. So I'm going to add these together. 6x plus 5x gives me 11x. Negative 8y plus 8y cancels. And that equals negative 20 plus 2 gives me, not plus 2, plus negative 2. I forgot that negative in front of there. Negative 20 plus negative 2 gives me negative 22. Now I divide both sides by 11 to get x by itself. Negative 22 divided by 11 ends up giving us negative 2. Now I plug that back in to solve for y. Again, it doesn't matter which equation we use. I'll pick the second equation this time just for fun. So I have 5 times negative 2 plus 8y equals negative 2. 5 times negative 2 gives me negative 10 plus 8y equals negative 2. Add 10 to both sides. I'm left with 8y equals negative 2 plus 10 gives me 8. Divide both sides by 8, and 8 divided by 8 gives me 1. So now my answer is my x value is negative 2, and my y value is 1. There is my answer. 1c. Okay, now we have another set of systems of equations. We have x minus y equals 9, 7x plus y equals 7. There's a couple methods that would probably be the best method to use here. We'll solve this one doing both. First of all, we could solve this one using substitution. I actually have 3 variables that are all by themselves. There's no coefficient on those variables. This x has no coefficient, this y has no coefficient, and this y has no coefficient. So substitution may be a good bet in this case. I'm going to do that one on the left-hand side. So probably the easiest variable to get by itself is going to be this x. So I have x minus y equals 9. I add y to both sides. I'm left with x equals y plus 9. Okay, now I can plug y plus 9 in for x in that second equation. So I have 7 times, maybe, 7 times y plus 9 plus y equals 7. I distribute that 7, so I have 7y plus 9 times 7 gives us 63 plus y equals 7. I can combine some like terms here. I have 7y and y, which is like 1y. 7y plus 1y gives me 8y plus 63 equals 7. I subtract 63 from both sides. I'm writing it at an angle now, I apologize. I have 8y equals 7 minus 63 ends up giving us negative 56. Maybe. Divide negative 56 by 8, and I'm left with y equals negative 7. Okay, now I plug that back in. Remember, it's probably going to be easiest to plug it back into this equation right here. Oh, my pen is not really cooperating. I apologize. So I have x equals negative 7 plus 9. Negative 7 plus 9 gives us 2. So x equals 2. So my answer here is 2, negative 7. You might have also seen that this particular one, it may be good to do elimination because I have negative y here and positive y. I can very easily eliminate that y. So I could also do elimination using addition. So I'm adding those two equations together. All right, so if I add these together, I have x minus y equals 9, and I have 7x plus y equals 7. So if I add those together, 1x plus 7x gives me 8x. Negative y plus y cancels, and 9 plus 7 gives us 16. I divide both sides by 8, and I get x equals 2. 16 divided by 8 is 2. I can plug that back in, probably into the first equation. That'll be easiest. So I have 2 minus y equals 9. Subtract 2 from both sides. I have negative y equals 7. Divide both sides by negative 1. Remember, this is like there's a 1 in front of that y. So I got to get rid of that negative. I'm left with y equals negative 7. So again, my answer is 2 comma negative 7. So you'll notice here that we got the same exact answer no matter which way we did it. So both of these methods are valid. It just depends, A, which one you prefer, and sometimes one is just smarter than the other to do. This one both gave us roughly the same amount of work to do. So they're both pretty good ways of solving this. So this next one, again, a couple ways we could do this one. There's no coefficient in front of that y, so that means there's no coefficient there, so that means I could do this one using substitution. This one also might be good to use elimination because We have a negative y here and a positive y here. And I could easily multiply that first y times 2 to get negative 2y plus 2y, where my y's would eliminate. So it also might be good to do elimination using multiplication. So both of these are good methods. I'm not going to solve it both ways on this one, but just know that that works no matter what. I'm going to go ahead and do elimination using multiplication. I'm a little bit more partial to elimination. I like it, and I know some people like whichever method, and it's fine if you have one that you prefer. I'm going to go ahead and multiply this first equation times 2. So I have 10x minus 2y equals 17 times 2 gives us 34. Ooh, 34. Okay, so now I'm going to combine these two equations. 3x plus 10x gives us 13x. 2y minus 2y cancels. That equals 5 plus 34 gives us 39. I divide both sides by 13 to get x by itself. 39 divided by 13 you'll find is 3. I'll plug that 3 back into one of the equations to solve for it. Again, it doesn't matter which one. You can do whichever one you want. I'll go ahead and pick that second equation just for fun. Again, it doesn't really matter. So I have 3 times 3 plus 2y equals 5. 3 times 3 gives us 9 plus 2y equals 5. If I subtract 9 from both sides, 5 minus 9 gives us negative 4. Divide both sides by 2. And I have y equals negative 2. So my answer here is 3 comma negative 2. And we're good to go there. Now we have a real world example. This says, of the 17 species of penguins in the world, the largest species is the emperor penguin. One of the smallest is the Galapagos penguin. The total height of the two penguins is 169 centimeters. The emperor penguin is 22 centimeters more than twice the height of the Galapagos penguin. Find the height of each penguin. All right, so looking at this word problem, up until this point, those first two sentences, they just tell us some information about the penguins. That might be helpful to check our answer, but not so helpful in writing a system of equations that we can solve. So again, we're trying to find the height of each penguin. So I might let E be the height of the emperor penguin. I can't spell, it's fine. Don't tell your English teacher. Then I might let G be the height of my Galapagos penguin. That's what I'm trying to find. Those are my unknowns. So I'm going to write some equations. First of all, this first sentence, the total height of the two penguins is 169 centimeters. Again, total is kind of like a sum, so that means I'm going to be adding. So if I add the two heights together, it's going to equal 169 centimeters. So I'll go ahead and make E plus G equal 169. So the height of the emperor plus the height of the Galapagos. Then the emperor penguin is 22 centimeters more than twice the height of the Galapagos penguin. There's our second equation. This one's a little bit more difficult. So I know the emperor penguin is, so the emperor penguin equals 22 centimeters more than, which means I'm going to be adding, twice, which means I'm multiplying times 2, the height of the Galapagos penguin. So 22 more than twice the height of the Galapagos penguin. So there you have a system of equations that you can solve. What I want you to do is go ahead and try to solve this, and we'll go over this in class tomorrow. But think about which method might be the easiest. In this case, you already have a variable that's by itself at E, so it might work best to substitute 22 plus 2g in for this E up here. Go ahead and try it, and we will go over it in class.